So now we're going to be doing experiment 5 for our electronics labs. Now up until experiment 4, we've been dealing with what are known as passive components. All that basically means that the job they need to do requires them to take a small part of the input voltage to function. A clear way to see that was experiment 4, where the diode did take away part of the input voltage to limit the current direction. So to get over that, we introduce active components. Now an active component, such as this IC chip or integrated circuit chip, comes with its own power supply. So any job it has to do, it uses its own power instead of taking away from the input of the circuit. Okay, so when it comes to this integrated chip, you'll see that it has 8 legs, 4 on each side. Now to identify the top of the chip, so you can count the legs or assign numbers to the legs correctly, you'll see at the top of the chip that there's a little divot there. Okay, now to count the legs or number them, we'll start at the top left-hand side of the chip. That'll be your pin 1 or leg 1, and then we go down to pin 2, pin 3, and we end at pin 4 on the bottom left-hand side. And then you come across to the bottom right-hand side, which is pin 5, and then you go up to pin 6, pin 7, pin 8, which is your top right-hand side. Then as with all these components, we always want each of the legs to have its own potential. So we accomplish that with this chip by simply inserting it across one of these gaps. Because as you recall, the voltage does not extend across the gap here or to rows below and above. So that now has that each of the legs or pins of this chip has its own potential or voltage. Okay, so the first important connections to make for one of these chips are its power supply. You get its lower power supply, which connects to pin 4, which we'll start off with in part 1 of the experiment, going to ground. So all I'll do is take this white wire connecting to the same voltage line as pin 4, and then the other side of the wire will go to ground. Then for our higher power supply, which is connected to pin or leg 8, we want that to go to positive 15 volts from DC source, and how we'll get that is by adjusting the variable DC on our breadboard until we get to 15. So I can use the oscilloscope to test that out. I'll just use channel 1. So we'll go to measure for channel 1, and we want our Vmax. Okay, so then if I place it along this brown wire here, we'll see now that it's currently at 10, so I'm just going to adjust it up until we get the desired 15 volts. Okay, so now we've got our chip correctly powered. So now we want to start making our specific connection to the chip, and how we're going to do that is we'll start with the input of the chip. Now the input is going to be to pin 5 of the chip, the bottom right-hand side. So I'll just take this red wire, attach it along the same voltage line as pin 5, and then we're going to be using AC input. So I'll just plug it to the out point at the top of our breadboard. Now the next connection we want to make is using the 2 resistors. In this case, we're working with a 1 kilo ohm and a 2.2. And as usual, when we introduce new resistors, we need to measure their exact value using the multimeter. So I'll just place my 2 resistors along 2 different voltage lines on the board to make it easier to measure with the multimeter. Okay, so our multimeter, we're going to set it to 20 kilo ohm region again, and then we just touch one probe to each side of the resistor. So we'll see for this one, our 1 kilo ohm resistor is actually 0.98 kilo ohms, which we'll take note of. And then our 2.2 kilo ohm resistor is 2.2, which we take note of. Okay, so now to continue our circuit on our IC chip, what we want to do is take our 2.2 resistor and we're going to connect one side to the same voltage line as our IC chip pin 7. Okay, and then what we want to do is take our 1 kilo ohm resistor. We're going to go from the one side of the 2.2 to its own voltage line. And then the output of this 1 kilo ohm resistor is going to go to a ground. And then the final connection we need to make is to join the point between the two resistors, the 1 and the 2.2, to pin 6 of our chip. Okay, so we're going to we can use channel 1 of our oscilloscope to be our input. So that's going to go where the red wire from our AC out joins our chip at pin 5. And then our output is going to be along the voltage line of pin 7. Okay, so now to set the correct input type, what we want is a square wave and a frequency of 1 kilohertz. Okay, so now what we'll see on this screen is we've got this square wave of our input here, okay, and then what for our output we've got this weird bumpy straight line raised up. Now the reason because of that is we haven't given our chip the correct power range to work with, because you'll see our input varies from positive to negative. So in order for the chip to generate a proper output, it needs a positive and negative range to work with. But we initially set our output to ground. Sorry, our negative power supply to ground. So we're basically giving the chip 0 to 15 to work with, but we wanted to be able to generate an output that goes from negative 15 to 15. So it shows you how it's important to power your chip with the correct thing. Now all we're going to do for variation for this one is first thing we want to do is get our correct measurements on the table up. So what we want is to show our Vmax of our input and our Vmax of our output. So if I go to measure, change to source 2, Vmax, okay. And then we also want the Vmin of our output. Okay, so the changes we're going to make for this circuit is we're going to start with our our Vmax of our input to be 5 volts. Then what you're going to do is take note of these values in the table you'll be provided. And then for this one, we also want to take a picture. Okay, so you're just going to take a picture of what we have on our oscilloscope screen. And then we're going to decrease our input voltage to 4. Take note of the values, but you don't need a picture for this one. Then we'll decrease to 3. Take note of your values in the table provided, take a picture, and then finally we'll go down to 2, and you just take a note of the values. Okay, so that's the first part of part 1 of experiment 5. So now what we want to do is see how our output changes if we give our chip a proper range to work with. So what I mean by that is now instead of giving it a lower power supply of ground, we're going to give it a power supply of negative 15. So the first thing we'll do, we can just use our probe or channel 1. We'll go to the variable 15, and we're just going to adjust it until our Vmax 1 gets to negative 15. Okay, and now we're going to move the white wire, that is our lower power supply, to that variable DC to get our negative 15. And then we just plug into the same input for our chip, which was where the red wire joins pin 5 of our chip. And our output is going to be pin 7 of our chip. And now we can see we get a much nicer output because we've given the chip the full range to work with. Okay, so just like before, instead of decreasing from a higher voltage, we're just going to start at the lower 2 here. We'll record our values there, our Vmax for our input and our Vmin and Vmax for our output in the table provided, and you'll also take a picture of this. Then we'll increase to 3 volts. You'll just record the values this time, we don't need a picture. And then we increase to 4 volts. You'll record your values, but this time we do want a picture. And then finally, you'll go up to 5 volts. You'll record the values again, and then we also need a picture for this one. So now for part 2 of experiment 5, what we'll need in terms of components is we've got the 2.2 from part 1. Since it's the same one, we know what its exact value is, so we don't need to measure again. Then we'll also need the 1 kilo ohm from part 1, know its value. But then we're introducing a new resistor to this experiment, the 4.7. So we have to use our multimeter once again to determine what our exact voltage is. Okay, so we're on the 20 kilo ohm range again. One probe to one side of the resistor, other probe to the other side. And we see our exact resistance is 4.6 kilo ohms, so you'll take note of that. Okay, so as always with these chips, the first thing we want to do is give them their power supply. So for this part of the experiment, what we're going to power our chip with is for the lower power supply, or pin 4. We're going to go to the fixed negative 5 volts. Okay, and then for our higher power supply at pin 8, what we want to do there is just use positive 5 volts. Okay, so it's always best to just double check that these are giving us exact 5 volts. So we'll measure them, and if they do vary, we can take note of that. So I'm just going to use channel 1 of the oscilloscope again and say measure Vmax. Okay, so we'll just touch to our positive 5, and we see it's giving us exactly 5, so that's good. And then if we go to our negative, we'll see in this case it is only giving us negative 4.6, so you need to take note of that. Okay, so now we've got our chip powered. Now we want to start setting up our specific connections for this circuit. So where we'll start is just by grounding pin 5 of our chip. So I'll take this brown wire, go to the same voltage line as pin 5, and then just connect it to a grounding point on our board. Okay, then the next connection we want to make is to pin 6. What we'll need for that is first our RA, our 2.2 kilo ohm resistor. Okay, so we need to connect that one side of the resistor to the voltage line of pin 6. Okay, and then to that resistor, we're going to use our AC input. So I'll just use the red wire to connect the resistor to the out points in our breadboard, as usual for an AC circuit. Okay, so now we're going to take our 4.7 kilo ohm resistor. One side is going to be attached to pin along the voltage line of pin 6, and then the other side will go to its own independent voltage line. To start off this part, we're going to have that 4.7 connected to a positive 5 DC volts, which I'll do with this pink wire here. Okay, now for our 1 kilo ohm resistor, what we want to do is use it as a bridge between pin 6 and pin 7. But instead of trying to contort it into a weird shape and risk damaging it, all we do is we connect one side of the resistor to the pin 7, and then the other side will go to its own independent line, but then we just use a wire to connect that other side of the resistor to pin 6 where we need it. Okay, then that completes the setup here. Now the input for this circuit, we're going to use our variable DC on our breadboard. We'll start off with a higher range of 0 to plus 15, and then we'll move to ground, and then to the 0 to negative 15. Okay, so our input will be from the 2.2 kilo ohm resistor to the positive DC variable. And now we're going to use our probes. Channel 1 will be the input as usual. That's going to go where the red wire meets the 2.2 kilo ohm resistor. And then our output is going to be pin 7 of our chip. Okay, so we want to start off at our maximum voltage, which we'll use 8 volts. So I'll adjust this variable DC until our Vmax of the yellow, our input, is at 8. Okay, and then you'll record your Vmax of your input and your Vmax of your output in the table provided. Then we're just going to decrease to 6 volts. You'll record your values in the table provided. Then we'll go to 4, 2, okay, and then we're going to move our input wire, the red one, to ground first. You'll take note of your values in the table provided, and then we're going to move our input wire, the red one, to the negative 15 variable DC, and we'll start there at negative 2. You'll record your values, and then we'll decrease to negative 4. Record your value, then -6, and we'll end with -8. So there's no pictures to take for this part. You'll just be recording your values of Vmax output and Vmax input. And then that'll complete. Oh no, sorry. Then for the next part, the change we want to make is, if you remember earlier, we had our 4.7 kilo ohm attached to the positive 5 DC. Now what we want to do is move it to the -5, and we'll repeat the same steps again. But just to shortcut it, if we just, because we already adjusted the lower one to -8, so you can start with there. So we'll have our input same place, the red wire meets the 2.2, and our output will still be pin 7. And now what we'll do for this one is we'll start at the -8, we'll record the values in the table, and then we'll increase to -6, record the values -4, -2, move the input red wire back to ground, take our value, then we'll move it to our positive range. You start at 2, up to 4, 6, and 8. So all we're going to do is go to those different input values and record our exact value as well as our output value, and that'll complete the results for part 2 of experiment 5. Right, now for part 3 of experiment 5. To set up our circuit, we always start by providing the power for our chip. So how we're going to power for this part of the experiment is we want our lower power voltage to be -15 volts from the DC supply. So I'll attach pin 4 of our chip with this white wire to the 0 to -15 DC source. And then using this pink wire, I'll attach the higher power supply of our chip, pin 8, to the positive 0 to 15 DC range. Okay, so we're going to use the oscilloscope to verify what our power supply is. So I'll just use Vmax of channel 1. So I'll move my probe to the pink wire. Okay. And we'll see there we've got our 15 volts, so we've got the correct higher power supply. And then I'll move my probe to the white wire, or pin 4. And we'll see there we've got a correct power supply of -15 volts. So now we know our chip is properly powered. Okay, so the connections to make for the chip for this experiment, the first thing we want to do is connect pin 5 of our chip to ground. Okay, then the next connection we want to make is we can connect our 4.7 kilo ohm resistor. Now this is the same 4.7 we used from the previous parts, so we know what its exact resistance is and we don't need to use the multimeter again. So we're going to use this to connect to the same voltage line as pin 6 of our chip. Okay, and then the input for this part of the experiment is going to be an AC. So I'll connect the resistor, the 4.7 resistor, to our AC output of our board with this red wire. Okay. Then the next thing we want to do is use our 1 kilo ohm resistor to bridge pin 6 and pin 7. So just like the previous part, of the experiment. Instead of trying to squeeze this resistor into two adjacent holes, we will connect one side of the resistor to the same voltage line as pin 7, and then the other side will go to its own voltage line, but then I'll use this yellow wire to connect the other side of that resistor to pin 6 as we need. Okay, all right. Now that we've got the circuit set up for part 3, we can use channel 1 of our oscilloscope to monitor the input of our circuit, and channel 2 of the oscilloscope to measure the output. So the output will be at pin 7 of our chip, and the input will be where the input from our board meets our 4.7 kilo ohm resistor. Now the starting conditions for our input, we want an amplitude of 2 volts, we want the sine type wave, and we want our frequency to be about 1 kilohertz. Okay, so I'll use the measure function to just get our frequency for our input. And then we want our Vmax for our input. And then finally, we want our, for our output, we actually want the Vmin. Okay. Right. Okay, so now we're going to take note of what's on the screen in terms of our Vmax of our input and our Vmin of our output. We will record that in the table that's provided. Okay. Then you also want to take a picture of this, of what's on the oscilloscope screen. And then all we're going to do to make changes for this experiment to get different outputs is we're going to first start by fixing our 4.7 kilo ohm resistor, so the one that's getting fed by our input. We're going to keep that one fixed, and then we're just going to change our 1 kilo ohm here to different resistances. So once you finish taking your readings for the 2.2 kilo ohm resistor for your output, okay, we're going to now change that to different values of resistance according to the table you'll be provided with. Okay, so once you get your final resistance done from varying your output there, what we want to do next is leave our output resistor fixed, but vary our input resistor. So what we're going to fix our output at is our 15 kilo ohms. So I'll remove this 2.2 kilo ohm resistor that's currently our output resistor. And now, because we're using this new 15, as usual, you want to check what its exact value is using a multimeter. So I'll set my multimeter to 20 kilo ohms, place one probe each side of the resistor, and we'll see this resistor is 14.93 kilo ohms, which we'll take note of. This now gets put into pin 7 and remains fixed for the last part of the experiment. Okay, so now what we want to do is we're going to measure input and output at the same point. So input is channel 1, which goes to the red wire, meets our 4.7 kilo ohm currently. Then we're going to plug our output wire to pin 7. Okay, we'll take note of the values there, our Vmax of our input, the yellow, and the Vmin of our output, the blue. Then what we're going to do is you'll see in the table you provided that we'll be changing our 4.7 kilo ohm resistor to different values and seeing what effect it has on the output. So for example, if I change that 4.7 to a 10 kilo ohm resistor, obviously because it's new one we're working with, we need to check its exact resistance again. Okay, so now with our output resistor, the 10 kilo ohm fixed, what we want to do is change our input resistor and see how that affects our output signal. So I'm going to replace this 4.7 input resistor with a 10 kilo ohm, but since we're just introducing this 10 kilo ohm, as usual, we want to measure what its exact resistance is. So I'll set the multimeter to the 20K range, one probe each side of the resistor, and we see that this resistor is 9.97 kilo ohms, which we'll take note of. Okay, so now we're going to place this 10 kilo ohm resistor as our input resistor. So we know one side is going to join the same voltage line as our red input wire, and then the other side is got to join to the same voltage line as pin 6. Okay, then to see what our input and output looks at, our channel 1 input will go to where our new 10 kilo ohm and the red wire meet, and our output goes to the same place as before, pin 7. Okay, and then you'll take note of our Vmax for our input and our Vmin for our output and record that in the table provided. Then we'll just change to different resistors for our input based on what's given to you in the provided table, and you'll just record what the output values are, and for every even output you'll also take a picture of what you see on the screen. And then that concludes part 3 of experiment 5 and in experiment 5 entirely.